Hello everyone. Good morning. Um, mm, we will start the class after 5 minutes to the other students can join us. Waiting 5 minutes and after 5 till 7 minutes, and then we start our class. Thank you very much. Hello everyone, how are you? Do you have my voice? Is it clear for all of you? Hi. Mm. Hi. Okay. Again. We wait 3 or 4 minutes more. And then start the class because as I said before, it is a system of problem. And usually at the first beginning of the class started. Please let me know about my sound quality. Is it still a problem? Okay, very nice. Okay. Okay, so nice. Hi again and good morning. Hope everything is well with you. Uh, and today we want to continue our discussion with the explanation about other components of microcontroller. However, in previous session we had some explanation and description about the different components of microcontroller, and today we want to explain the rest of the our discussion and try to finish this section if we have sufficient time. Then from next session we will have some another explanations about microcontrollers. And so after that, as I said, we will have a review about C language and so on. The other chapters, meanings related to the applications of microcontroller and so on. So one of the components of microcontroller is called timer counter. Actually, these components provide all timing and counting functions inside the microcontroller, and the major operation of this section are performed clock functions, modulations, pulse generators, frequency measuring, making oscillations, and so on. And this can be used for counting external pulses too. And actually a microcontroller may have more than one timer counters. In next slides, you will be more familiar about, for example, our introduced microcontroller Atomica 32, and you will see that this microcontroller is including 3 timer counters. However, in next slide we will pay more about them and explain about that. The other components are called parallel ports. Actually, they provide various serial interfaces between microcontroller and other peripherals, for example, parallel ports. As you see in the figure, we have interfacing, for example, with one of the peripherals of microcontroller. We have receiving, transmitting, and reference line, which are using for exchanging data, transferring, receiving, and transmitting of data between our microcontroller, different peripherals. The other components of microcontroller is interrupt sources. Interrupt sources are the interrupts actually themselves are the events that temporarily suspend the main program, and they are provided by interrupt sources. Then interrupt themselves are events, and they suspend our main program, which are provided the interrupt sources, meaning that interrupt sources provide us a suspending of program. And the other component is called PWM function block, which is a built-in timer, and it can be used to generate a PWM signal. PWM signal is PWM is the abbreviation of pulse width modulation, and it's actually square waveforms. As you see, this is PWM modulation resulted waveform, which is an square waveform, as you see. Another component is analog to digital or digital to analog converter. At first, I want to explain about analog to digital. However, digital to analog converter is also performing reversal operation of analog to digital conversion. But what is analog to digital conversion? It is used for converting the analog signal to digital form. Then the input input signal about it should be analog form, for example, sensor output, and the output form from this converter of microcontroller is a digital form, and the signal output can be used for various digital applications, for example, measurement devices and like that. But about microcontrollers, we have different architectures because we want to talk about the AVR microcontroller at Mega 32 or 16. I want to discuss the architecture of AVR. Actually, a moment, please. A moment, sorry. Do you have my voice? Please let me know. Okay. I was talking about the AVR architecture. Okay, thank you. Actually, AVR is using RISC or reduced instruction set computer modified Harvard architecture, meaning that actually at first we are using Harvard architecture, meaning that it has separate buses and memories for data and program. Actually, instructions in the program memory are performed with a single level pipeline, with this meaning that while one instruction is being achieved, the subsequent instruction is performed, perfected, and then we can say that Harvard architecture contains separate storage and separate buses, signal paths for instruction and data. About the Harvard's architecture, we have two types of architecture. Which one of them is called RISC, or as I said, reduced instruction set computer. The other one is CISC, or on the other hand, SISC, which is complex instruction set computing. About our considered microcontroller, which is at mega 32 or 16, the architecture is Harvard architecture. Which type? RISC type, reduced instruction set computer type is used. As I said, the purpose of this structure is to be shorten the runtime by reducing the set of components on the computer. Actually, the use of RISC architecture also made it possible to program in high-level languages such as C and BASICs. About the advantages, not only it's including disadvantages that I mentioned you. It is scalable. It has same powerful AVR core in all components. It is single cycle execution. One instruction per external clock. It has also 32 working registers, which all of them are directly connected to ALU. I explained about ALU previous session, if you remember. It has very efficient core. Low power consumption is from other features of this architecture. It has a high system level integration, and also lowest total system cost is another characteristic or feature of AVR architecture, which is called Harvard. Which type? RISC type. So here you can see the figure related to AVR microcontroller architecture. As you see, there are we have input output ports. Here you can see port B, port A, port A, B, C, 4 ports of our AVR microcontroller, A, B, C, D. These are 4 ports of our AVR microcontroller, and each of them, as you see, are including 8 pins. We have CPU of our microcontroller, AVR microcontroller. I explained about it, which CPU is including ALU and different registers. I also explained about different registers of our CPU, AVR microcontroller CPU. It's also including different memories, for example, EEPROM. I explained about it previous session, if you remember. And the other components that you can see here, for example, timer counter, I explained in previous slide. And other components, all of them are shown here, which are related to AVR microcontroller architecture, and the buses, as you see this line, which are using for interfacing different peripherals of inside the microcontroller with each other. But what are the buses? Actually, there are separate buses. There are separate buses for the code and control and data memory. Then we have three types of buses. For example, these kinds of question can be your midterm question. So please, every session have a study about them because they are so important, and everyone who passes a microprocessor or microcontroller course should have some information, elementary information about its architecture, the architecture of a microcontroller that is explained. So because there are so many information about first slides which are explanatory, it's better to have a study each session about them to not be confused at the midterm exam or final about this part. As I said, buses of Harvard architecture or buses of AVR architecture are three types, three separate types. One of them is for code, the other for control, and the other one is for data memory. Do you have a screen sharing? Okay. One of the students said that he can't say the material, the screen related to the material. Then because of that, I asked about the problem. Okay. I want to talk about these three types of buses. The address bus allows the CPU to send the address to other components such as RAM, input-output devices, and it is bidirectional. This is O here, it is typo. Input-output devices, the devices which are connected to the input and output of microcontroller. And it is bidirectional. As you see here, the second line, it is it is actually address bus. As you see, it has only one side direction, and it is in this side. But two others, meaning that this one and upper and lower one are called data bus and control bus, and they have two direction in both sides. So data bus carries data, first line, carries data between CPU and other components, SRAM, EEPRAM, timer counter, interrupt units, input-output ports, and or other peripherals which are connected to our system or are inside our microcontroller chip. And the other bus is a control bus, and it is actually the communication between address bus and data bus. It is used for having communication between these two buses. And as you see, it is unidirectional. It has two sides of direction, but about address bus is not the same. Only it has one direction. Or on the other hand, it is bidirectional. Okay, as I said about at Mega 32 or 16, we have four input-output ports.
port A, port B, port C, and port D. You see here, it is port A, including 8 pins, PA0, PA1, port A2, port A3, port A4, and till port A7. These are the pins related to port B, port B0, port B1, PB2, PB3 till PP7. It's also including 8 bits, or sorry, 8 bases or pins. These are port D's pins PD0 till PD6, and this is PD7. Then it's also including 8 pins, and about port C we will have the same thing. Each of these pins can use for different purposes. As I said about AVR microcontrollers, we will have a timer counter. I said that different microcontrollers are including different number of timer counters. About at Mega 32 or 16 that we want to talk about it. The number of timer counters are it's including a 3 timer counter, T1, T2, or timer counter 1, timer counter 2, and timer counter 0. Timer counter 0 and timer counter 2 are 8 bits, and timer counter 1 is 16 bit. Another feature is parallel ports or serial interface, which is related to pin 14 or pin 15, which is related to D ports pin. As you see, RXT and TXT are related to parallel port or serial interfaces. Interrupts timer counter or analog to digital converter. About these parts, any function has its own interrupts. We will have 2 PWM, this is W, generators, OC1A and OC1B. OC1A, OC1B. One of the ports of our microcontroller is related to OC1A, which is 19 pin, and OC1B, which is 18 pin of our at Mega 32 or 16. It's including 8 analog to digital converter pins or bits, and also a reference, a GND or ground, and a VCC. All these pins related to analog to digital converter are actually related to port A pins, PA0 till PA7, are used for analog to digital converters. As you see, AD0, analog to digital converter 1, analog to digital converter 2, till analog to digital converter 7. I'm explaining about them. I don't know you can understand or not, but they are so easy. Every microcontroller has its own data sheet, and on data sheet all these data are explained and are as given data. For example, when you want to interface for example, analog to digital converter, you should use these pins for your interfacing. Please don't be confused about these explanations. Then, for example, for analog to digital converters, we are using pin A, or for example, for timer counter 0, we are using the first pin of port B, or pin 1 of our at mega 32 or 16. As you see, it is called T0, or timer counter 0. Also, as I said, we have about analog to digital converter pins. We have A reference, A ground, and AVCC. How we can connect these 3 pins? The connection would be as this one. AVCC would be connected to power supply, which is equal 5 volt, and then by using a capacitor, it is grounded. The capacitor value would be equal 100 nanofarad. And about AGND, or analog to digital ground, and the A reference. As you see, AGND is directly connected to the ground. This is our ground. And also a reference, by using a capacitor, it is connected to ground too. Here, AGND, or A ground, or ground of A port, which is used for analog to digital converter, is used to omit the noise of our system for having the best operation. Again, I want to have a description about the pins of our microcontroller. As I said, we have 4 pins. Again, I'm explaining about them. 4 ports: port A, port B, port C, port D. Each of these ports are including 8 pins. As you see, 8 pins related to our ports of our microcontroller. We will have reset pin 9 of our microcontroller. It is a reset pin. If a low level of voltage will be on this pin for longer than the minimum pulse length, it will generate a reset. We will have extol 1 and extol 2, as you see, these 2 pins, which are respectively 12 and 13 pins of our microcontroller. Extol 1 input to the inverting oscillator amplifier, and input to the external clock operating circuit, and extol 2 is output from the inverting oscillator amplifier. We have AVCC. I explained about it. It is the supply voltage pin for port A and analog to digital converter. It should be externally connected to VCC. I shown you the circuit related to connection of A ground, A reference, and AVCC, which are 3 pins, 32, 31, and 30 of microcontroller. The same I explained about A reference, which is the analog reference pin. This pin that is for analog to digital converter interfacing. What about the clock sources? AVR clock sources can be either internal or external. Internal clock sources. About internal clock sources, it is actually internal calibrated oscillator with the frequency, with the specific frequency of 1 megahertz, 2, 4, and 8 megahertz, which the microcontroller as a default usually use frequency of 1 megahertz. when we start to coding, you will face with this feature of a microcontroller. When you start to open the environment of the simulation or coding, you will have option to changing this value. If you want to have it as 1 megahertz, then you will fix it on 1 megahertz. If you want to change to other values, you can change it by pushing the related option for changing the frequency of internal clock source. However, sorry. Actually, internal clock source means the little oscillator inside the chip. It is a little oscillator inside the chip, and internal clock is good for basic, most basic projects, meaning that it's not very precious. Having an internal oscillator means we don't need to wire up an external crystal, and then we can use the clock pins for other tasks. What does it mean? It means that using internal clock, however, with the specified frequency and less being less precious, give us opportunity to use the pins of our microcontroller for other tasks. Sometimes we have so many interfacings for our microcontroller, and you know that the number of the pins of our microcontroller is limited. So we need to use, for example, most of the microcontroller pin. For example, we want to connect it to LCD, to keypad at the same time. Then we need the pins of our microcontroller. And for example, when we want to use clock sources, sometimes we need to use internal clock sources because it is internal and don't need to wiring up and using the pins of external clock sources. About this figure, I will explain after having discussion about next slide. Then I'll come back to this slide to having review about that. As I said, then our AVR is including two types of clock sources. Internal, I explained about internal clock sources. Then I want to talk about the different types of external clock sources too. We will have three type external clock sources. External clock signal, which has 22 megahertz. As you see, Xtal1 and Xtal2. Let me to show you on the pins of our microcontroller. Xtal1 and Xtal2 are related to 12 and 13 pins of our microcontroller. About these kinds of external clock, Xtal2 is not connected, but Xtal1 is connected to a square waveform, which is 22 megahertz. Another type of clock source is, or another type of external clock source is external RC oscillator. As you see, the same Xtal2 is not connected to is not connected, but Xtal1 is connected to a resistance, and then it is connected to power supply, VCC, and from the other side it is connected to capacitor, and then it's grounded. So Xtal1 is connected to R and C, which is oscillating the minimum value of C. Okay, now we can have different values for R and C, but the minimum value of C should be equal to 22 picofarad. Then the frequency of these external clock sources will not be limited, and it is somehow equal by 1/3 R C, meaning that it's related to the value of R and C, but by considering the minimum value for C, which is equal 22 picofarad. Another type of external clock source is external crystal oscillator, with the frequency of which is determined by quartz crystal. The quartz crystal can be 16 megahertz or 32.768 kilohertz. Then about this type, or about external crystal oscillator, we will have again two types. One of them, a frequency is equal this value, 16 megahertz, and the other one is equal 32.768 kilohertz. As you see about external crystal oscillator, XTAL1 and XTAL2, both of them have connection, and as you see, they are connected to a quartz crystal, which can be, as I said, 16 megahertz or this value, and then they are from both sides, XTAL1 and XTAL2, connected to capacitors with the value of 30 picofarad, and then both of the capacitors are grounded. About this type of clock sources, we are using quartz crystal with two different frequency related to the quartz crystal that we are using here. The frequency would be different. But as I said here, yes, in this figure, as you see, we have a clock multiplexer, and these are different clocks. As I said, it is internal calibrated clock. We said that we have internal clock and different external clocks, crystal clock, RC oscillator clock. I explained about it. All of them are going to clock multiplexer, and then from AVR clock control unit, it's applied for different components as analog to digital converter, CPU core, different memories, RAM, EEPROM, and so on. So it is the figure related to clock distribution. Okay, today also we didn't have a break because as I said, the first sessions are somehow boring and experimentary, but it is a part of your syllabus of this course, and we can't omit this part. It should be explained. Then I want to finish the class. I think it's sufficient for you to hear to this explanatory part. Actually, I have suggestion. If you accept, we can have our class from 10 o'clock. Is it okay with all of you? From next session, of course. Okay, then if it's okay, why Ismail? Why 9 is good? If one of the students don't accept the situation, we will have our class from 10 o'clock. No, Actually, I think we will have four other sessions that we can finish our class in 1.5 or 1 hour, because as I said, we have four next sessions which are experimentary, and then about the online classes. We will finish our class in 1 hour or 1.5 hour, so it doesn't take so long. And as you see, I don't have break, and I start the class and then finish the class without any break. Anyway, I'll send the email for all of these students. If all of you are agreed with the situation, we can start the class from 10 o'clock. Thank you very much. If you have any question, you can ask your questions. Yes, dear Efekan, I don't know I spelled your name incorrect or not. As you remember, in first session, I talked about it, and if you refer to the lectures PDF file that I sent for you, in first slide, you can find the reference for that. Thank you very much. Have a nice time. I want to finish the class. If you don't have any question, uh, I can finish the class. Any question? What is STESTM? You mean that at Mega 32? You're talking about this kind of ABR? It is related to the syllabus of the course. Yes, at Mega 32 or 16. It is related to the syllabus of the course, because in most of the universities, this type of yes, I understand. In most of the universities, this type of AVR is used. This type of microcontroller is used. It is user friendly. It's easy to understand and also easy to coding. Then because of that, most of the universities are using this type of uh, mm, uh, microcontroller for explanation in their syllabus, and we are following in the world strategy about this course. Any other question? Then, as I understand, there isn't any other question. Uh, 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 okay, I want to say something. This class is including 80 attendant, okay? Uh, and if I want to send the lectures one by one to each of the students, it would be so difficult for me, and I think it is impossible. Then from OIS, I'm sending the lectures for all of the students. The PDF files that I explained here, I'll sending each session to all of the students. It's better to check your OIS mailing box, and I'm sure that all of the students receive the emails related to the iOS. Otherwise, you have problem about receiving the email. Okay, thank you very much. Have a nice time and bye-bye.